Welcome to a video on how to find trig ratios given angles. So this video will concentrate on how to do this with degrees, and the values of trig that we'll be finding is the special triangle angles and quadrantal angles as well. So you're going to learn how to basically find trig values without using the calculator at all. So with special triangle angles, when you're given an angle like 225, for example, you're going to have to find the related acute angle first. And so when you're drawing this will be in quadrant number 3. And the related acute angle here will be 45 degrees. So when you're drawing this, draw it more or less to scale so that it's easier to tell that this is an isosceles triangle, that this side will be 1, 1, and this will be the root 2. You should also fill in any negatives. Think anything to the left is negative and anything down is negative. So we have to the left of origin, so we have a -1 here, and down from origin, so that's also a negative. After you filled in the triangle, all you have to do is think of the definition of cosine. Definition of cosine is x over r. And all you have to do is just pick out the numbers that you recorded from the triangle. X is the horizontal value, and the radius is root 2. So the only thing left is to make sure that it's written in proper form. So you rationalize by doing multiplication up by the root 2, both top and bottom. So final answer is this. So the steps of finding ratios from special triangle angles are as follows. You would draw the angle in the proper quadrant like we did in this one, quadrant 3. You label the triangle sides based on the related acute angle. Just keep in mind also when we're doing another angle, not the 45-degree angle, this one was an isosceles, but if it's not an isosceles triangle, that you should remember that smaller side is across from a smaller angle, bigger side is across from a bigger angle, so it's going to be quite easy to actually label and figure out where the root 3 goes, where the 2 goes, and where the 1 goes. Then you fill in any negatives, and then you use the trig definition. When you use the trig definition, do not write cos anymore. So notice here is cosine of this angle. The output now is the ratio. There is no longer cosine attached to this answer. All right? And the steps for the quadrantal angles, you are to draw the angle. So this 270, for example, we would draw the angle, and it rotates and falls over here. You're supposed to label the point of a unit circle because we don't really have a triangle here. So the radius here is 1 because it's a unit circle. And you don't have to draw the circle, but here it is. The point down here is going to be 0, -1. This is the x value. This is the y value. And then all you have to do is use the trig definition. Tangent is y over x, or rise over run. I'd like to think of tangent as slope. So slope of this terminal arm is actually undefined, and you can see that by plugging in y is -1, x is 0, and that is undefined. In the next example, we have a negative angle, so rotating in a negative direction would be actually rotating clockwise. So here we've been rotating in this question counterclockwise to 70 degrees, here counterclockwise to 25 degrees. This time we're going clockwise 60 degrees. When you're drawing this, I would recommend that you draw this to scale. So don't put it where I'm putting the green lines. Don't put it just randomly in the middle or somewhere closer here, because that's not the 60-degree angle. And if you do it that way, it would be hard to tell where the smaller side is of a triangle. So try to put it more or less to scale. Draw the triangle always towards the x-axis, never to the y. So the triangle you draw always hugs the x-axis, like in the example here. It was drawn towards the x-axis, same thing here. So this angle here is 60. So the related acute is always positive, so you don't have to put a negative in there. And now that you drew it more or less to scale, you can totally tell which side is the smallest. So you see this side is shorter in comparison to everything else. So this is the side 1. Then radius will be the longest side, which is side 2. And the remaining one is root 3, which is across from 60. So 60 is not the biggest angle. the biggest angle is 90. So 90 is the biggest angle, so it's across from the biggest side. 60 is in the middle, so this is the side that's also in the middle across from it. And then 1 is across from angle 30, which is the smallest one. So now we've labeled it. Now we just need to fill in any negatives. Anything to the left and anything down is negative. Radius is never negative. So this radius looks like it's down, but you never labeled the radius negative. So the y value here would be negative. The x value will remain positive. And so the definition of sine is y over r. And so negative root 3 over 2 is the final answer. Okay, we have a few more. In this question, we have a secondary trig ratio. It doesn't change the steps of our work. We just know the definition for cosecant is r over y. But before we do that, we need to draw the picture. So angle 120 degrees falls into quadrant number 2. And the related acute angle would be 60. So this is 120. This is 60. So again, draw more or less the scale so you could tell the shortest side is this x, and it's negative because it's on the left. Then this would be root 3, and it's positive because it's up, and radius is always positive 2. And then you fill in the r, which is 2, and y is root 3, and then rationalize to get it into proper form, and you're done. Okay, next question. Negative angle, 150-degree rotation. So when you rotate 150 degrees, you're going clockwise this time, and you're going draw a smaller angle here. And so the smaller angle, you could tell then when you're drawing the triangle towards the x-axis that this side right here would be the 1. This would be the root 3, and this would be the 2. Just fill in any negatives. And definition of secant is r over x. R here is 2. X is negative root 3. Rationalize. And this is the final answer. Okay, and cotangent of 135 degrees. So again, is this one just like D is in quadrant 2, but I'm going to draw it right down the middle. So when I draw the triangle, it looks on isosceles. Fill in the 1, 1, and root 2. Fill in any negatives, and then answer the question by doing the definition of cotangent x over y, which is negative 1 over 1, or just negative 1. All right, and there's 2 more questions here. They're expressions with trig ratios. So I'm going to ask you to do this one on your own. I'll just provide you the answer so you could check. And this one I will do right now. So what I like to do is actually write down the format of this. We're going to have a 2 multiplied with some sort of ratio, minus 3 multiplied with 2 different ratios. And we have to basically draw 3 different pictures to help us figure out these ratios. So I'm going to start off on the side here, just draw the 90-degree angle. It falls on the quadrant axis, so we have radius is 1, and the point up here is 0, 1. This is x and y. So cosecant, if you recall, is r over y. So the value I'm going to record in here is 1 over 1. Okay, then I'm going to draw a picture for, actually I have a picture, 135 is over here. And so tangent would be y over x, which is 1 over negative 1. And then 210, I don't have that picture, so I should draw that one. 210 is in quadrant 3. In quadrant 3, it's 30 degrees off. Actually, that's the same one as that one. I'm going to use this picture. So cosine is x over r. So we have negative root 3 over 2. And all you have to do is simplify this. So we have 2 times 1, which is just 2. We have negative times another negative times another negative. So overall is negative number, 3 root 3 over 2. And then you just do the common denominator. times 2 here times 2. So that would be 4 minus 3 root 3 all over 2. All right. I hope this was helpful. Thank you for watching.